Today we'll see what is static and dynamic linking. A linker is a program that combines object file into an executable program. Static linking, it links library on other code directly into the executable file during compilation. So all dependencies are included within the final program. It does not need to rely on external libraries at runtime to function, resulting in a larger executable, but ensuring compatibility even if the required libraries are missing on the system where it runs. Now, how this static linking works. Given a source code to compiler, and compiler will produce the output in assembly code. Now the assembly language code will be given to the assembler, and assembler is going to produce the object code. The linker links the object code or the assembly code into with other libraries to produce executable code. The executable file will be used by the loader to place in memory for execution. Some key points about the static linking. Compile time integration. Static linking embeds all needed library code into the executable during the compilation phase. Self-contained execution, as the program carries all necessary libraries within itself, it can run without requiring any additional libraries to be present on the system, resulting in a larger executable size due to the inclusion of all library code. Statically linked programs tend to be larger than the dynamic linked one. No dependency issues. Static linking eliminates the potential issue of missing or compatible libraries at runtime, as the program has everything it needs within its executable file. When to use the static linking? In embedded system, where there is a limited memory, thus ensuring complete functionality without external dependency is crucial. In some critical application where absolute stability and predictable behavior is required, even if the resulting file is larger. Next is the dynamic linking. It is a method where program linked to shared libraries at runtime rather than at the compile time. For example, DLLs on Windows and shared objects or .so files on Linux are the example of dynamic link libraries. How dynamic linking works. At compile time, the program references the function or resources that reside in the external libraries, but the actual memory address and code aren't copied into the program during the build process. Instead, the program keep track of what external library it needs, but doesn't include them. At runtime, when the program is executed, the operating system loads the necessary library into the memory, linking them dynamically to the program as it runs. It is often done through something like a loader or runtime linker. When to use dynamic linking? When we require the shared library and we need to reuse the code, and letting the multiple program to share the same library in the memory. In modular application, where splitting large application into smaller interchangeable components or plugins are required, the components can be loaded at runtime. In version management, dynamic linking makes it easier to update a shared library without recompiling all applications that use it, useful when bug fixes or performance improvements are made in a library. Reduced memory footprint. Dynamic linking can help reduce overall memory usage because shared libraries are loaded into the memory only once and can be used by multiple applications simultaneously.
So let us see how we are doing static linking. I have created a folder named static. I will just show you the list of files I have over there. So first of all, we are having add.c, volume.c, driver.c, and lib_mylib.h. So let me show you add.c. The contents of add.c is it's having a header file and a method named add, which is not returning any value. So void add and passing two parameters a and b. C is addition of a plus b and printing over there. Then next is volume.c. This program is of finding the volume of a cylinder, included two files, studio.h and mat.h for power. A method is there, volume, which is returning a float value, and two parameters are being passed, r and h of type integer. So it is returning pi r square h value. So just observe that we are not having a main method over here. It is just a method over here. Then next is nano lib underscore mylib.h. So this header file contains the method we have just seen, add and volume method in the two files add.c and volume.c. So we are putting here the definition of that. And last file is nano volume.c. Now if you observe this sorry, last file is nano driver. So nano is the editor. So we are including stdio.h and also the header file lib underscore mylib.h which we have just seen before this. Now this is a code where we are entering the two numbers and then passing on these two numbers which we have got into this method add. Add is present in add.c. Then next is getting the value of radius and height. And then we are printing the volume of cylinder. So for that, we are passing R and H into the volume function, which is there in the volume.c. Now next is we are going to compile this code and then we'll see the static linking. So we'll be using GCC compiler and we'll be passing add.c. So hyphen C is for compilation and hyphen O is for converting into an object file, add.o. So successfully done. Then hyphen C. Similarly, we'll do for the volume file, hyphen O, volume.o. So converting that again. Then next is PRRCS. So lib underscore mylib dot a add dot o. And now this command is AR command is used for creating static library, that is for linking compiled code into an executable program. RCS is used when we are making file to compile a library. R means that if library already exists, replace the old file within the library with your new files. C means create the library if it does not exist. S means create a sorted index of the library for faster access of the function in the library. Then lib underscore mylib.a is a static library file which contains functions that are linked to the calling code during the compilation. And we are passing over here add.o, this object file, and a volume.o to it. Next is we are going to compile driver.c with the same commands. So compile. And if I show you the list of files which have been created are add.o, driver.o, then lib underscore mylib.a, which we have done with the previous command, similarly for volume.o. Next is we are going to execute this exe file of driver, capital L dot and hyphen L underscore mylib. Okay. So this error is coming. To remove this, I am putting hyphen LM over here. Now this line is saying GCC is the compiler, then hyphen O is the object. So driver is your exe file. Hyphen small l search the library mylib when linking. Linker searches a standard list of directory plus any that you specify with hyphen capital L dot. Okay, so then next is we are going to execute the driver. So it is given, enter two numbers to add, enter the radius, and this is the volume of the cylinder. I hope you have got how we are static linking is done. Next, we will see how the dynamic linking happens. Okay, so I've created another directory for dynamic so that the code, there is no interference with the code. I'll just list over here. Let me just clear this so that, okay. Now I will show the list of files. So add.c, again, the same file being copied here already. Now with the dynamic linking, let us start. So gcc add.c hyphen c hyphen f pick hyphen o and add.o. So this command is going to generate a machine position independent code, that is PIC, suitable for use in shared library supported for the target machine. Hyphen O, as we have seen earlier, links the object file to C standard library and produces the executable code. Similarly, we'll be doing for volume.c hyphen C fpic hyphen O volume.o. Okay, so I have forgotten to type over here hyphen, which has created the error. Okay, so next is with the GCC hyphen shared hyphen O lib underscore mylib. So this file was already existing over there. Dot so add dot o then space volume dot o. Now this hyphen shared command tells the compiler driver to generate a shared library mylib.so, which comprises of object module add.o and volume.o. Hope this is clear. The next is we will export ld underscore library export path equal to dollar pwt, everything in capital, library underscore path. That's it. Everything in capital. Okay. So this ld underscore library underscore path tells the dynamic link loader ld.so where to search the dynamic shared library an application was linked against. Now, if there are multiple directories can be listed or separated by a colon, and this list is then searched before the compile in search paths and local standard locations like lib user or any other. Then let us move on. So gcc. So this is a command we have already seen with the static compiler compilation. So driver file was already there, driver.c. So making the executable file for this. Okay, so again, same lm is to be added. So it's getting compiled and slash driver for executing the driver code. So enter two numbers to add. So two numbers and entering the radius and height, and that's it. We got the volume of cylinder. So this is how we have seen how dynamic linking happens. Thank you.